One of the beauties of CockroachDB being a distributed system is the ability to perform rolling upgrades, the ability to upgrade one node at a time, resulting in zero downtime upgrades. However, if you're running across two data centers, you might be more familiar with blue-green or Canary deployments, sometimes collectively called progressive deployments. That's what we're going to be talking about today. I'll show you how to use CockroachDB's logical data replication. We'll upgrade via blue-green and Canary, all while running a workload that won't encounter any downtime. Let's look at the architecture diagrams for both of these scenarios and then dive right in. First, we'll perform a blue-green deployment. In this example, we'll have production traffic hitting a production cluster that will be unidirectionally replicating data via logical data replication to a staging cluster. And it's against this staging cluster that we'll run test traffic post our upgrade. So the production environment will be our blue deployment. We'll create a unidirectional logical data replication stream to a staging cluster. That will be our green deployment. We'll upgrade the green deployment, make sure we're happy with it before rolling out the same upgrade to production. With blue-green deployments, production users aren't exposed to the new version until it's been tested. Contrast this to Canary deployments, where we'll have production traffic hitting a load balancer that will point users to a production 1 cluster running the previous version of the software. And then we'll set up a bidirectional logical data replication stream to replicate data in both directions. So both of these clusters will function as production clusters. We'll update the production 2 cluster, and then we'll slowly point production users via the load balancer to the new version of the cluster. 10% of users go to the new cluster, and then eventually 100% of users to the new cluster once we're happy with it. If at any point we don't like the new version, we can always increase the proportion of users that are hitting the old cluster. But once we're happy with the new version, we can update the old version of the cluster, perhaps repointing users back to that, or at that point we might just switch the roles of the clusters. I'm using Kubernetes for this, and I'll create a production cluster and a staging cluster. With those set up, both of those deployments will expose a public load balancer endpoint, and I'll grab the IPs for those now. That's the IP of our prod cluster, and that's the ID of our staging cluster, and I'll make each of my terminals aware of both. And with these queries, I'll create the same schema in both the production and the staging clusters. And to simulate some traffic, I'll start a workload, and that'll be running against the production cluster. And now we'll run our upgrade scenarios. First, I'll do a blue-green deployment, tear everything down, and then do the same but a Canary deployment. But first, the blue-green. I'll connect to the production cluster, and then I'll run 3 commands. One will create a user with replication privileges that I'll harness from the staging cluster, and I'll enable range feeds. That's required for logical data replication. Next, I'll connect to the staging cluster and create an external connection to the production cluster. Note that because this is in the same Kubernetes cluster, I'm referring to the first pod of the production cluster. And finally, using the external connection, I'll create a logical data replication stream from all of the tables in the production cluster, replicating them into the same tables in the staging cluster. And within a few seconds, we'll start to see data coming over from the production cluster. And there we go, data is starting to come across now. Next, I'll run the same workload against the test environment. Now, obviously, if you have a very busy production environment, you might want to run a slightly scaled down version against your staging cluster. And this will serve as our test bed for the upgrade. I'll perform my upgrade by applying the next version of the image as a manifest. And I haven't got any error handling on here, and that's on purpose. You'll see anytime that this workload encounters an issue. And let's have a look at what we're actually doing with the nodes now. We've knocked out CockroachDB 2 and we've just upgraded it to the next version. In a second, that will go to ready. And we've just started the rollout of the next node. So we saw a couple of failed requests, and those were in-flight requests to CockroachDB 1, which has just been upgraded to the newer version. And finally, once that's up and running, we'll do the same to CockroachDB 0. And we'll probably see a few failed requests here. And there was a failed request there. Just jumping into the console now, this is our production cluster and it's running on 24.3.5. And this is our staging cluster and it's running on 24.3.6, the next version. With the rollout complete, the testing workload seems stable. So I'll now do the same against the production environment. And if I come back over to here, you'll see that in a second, one of these nodes will go from live to draining. And that's just happened. You can't really see it past my head, but it's just there. And eventually the cluster will realize it's running mixed versions of CockroachDB. So we'll get a little warning at the top. And there it is. There are 2 nodes running on version 3.5 and one node running on 3.6. Now there are two nodes running on the later version, and in a couple of seconds we'll see that that warning goes, and so too will the mixed versions text up here. That will just go to 24.3.6. And there we go. The cluster is now running 24.3.6. All of the nodes are running 24.3.6, and the cluster is now fully replicated again. That was our blue-green deployment. Now we'll move on to the Canary deployment. This is where both clusters will function as production clusters. We'll target 100% of traffic to one of the clusters, upgrade the second, and then slowly migrate users over to the second, the upgraded cluster. I'll spin up the clusters again. And with those both up and running, I'll grab the IPs of each of their external load balancers. And actually, they're using the same IPs as they were before, so no changes required. I'll recreate exactly the same schemas in both clusters as I ran for the first workload. But this time I'll start a very simple load balancer, making it aware of both the production 1 cluster. That'll be where we're sending 100% of the traffic initially. The second cluster, this is the one we'll upgrade, and then telling the load balancer to send 100% of traffic to the first cluster. I'll start my workload against the first cluster and I'll connect to it. As with our blue-green example, I'll set up a user that allows the other cluster to replicate data from it. But this time I'll do the same in the other direction. With this command, I'll replicate data from the second production cluster into the first production cluster. And with this command, from the first production cluster into the second production cluster. So logical data replication is now running on both clusters, and there's a bidirectional streaming connection between the two. I can now upgrade the second cluster. Note that there won't be any failed requests over here because 0% of the traffic is currently pointing to this cluster. And that's just gone to ready now. So the upgrade is complete. I'll now allow a small percentage of traffic, 25%, to go to the upgraded production cluster. Note that there aren't any errors occurring, which is a good sign. This means I can continue my rollout. And if we take a look at the metrics, we'll see that there has been a drop in traffic to the production 1 cluster, and that's because the production 2 cluster is starting to receive production traffic. Taking a look at the metrics on the production 2 cluster, we'll see the reverse. It's now starting to receive queries. Everything's looking healthy, so we'll increase the share of production traffic 50-50 across the clusters. Again, everything seems happy. We'll notice an uptick in our requests to the production 2 cluster. And there it is. We'll notice again another fall in traffic from the initial production cluster. And we'll keep reducing the amount of traffic that the first production cluster is receiving. At this point, 75% of traffic is now going to our upgraded cluster. Let's just finish that off. With that command, we just sent 100% of traffic to the upgraded cluster. So this will drop to 0, and the production 2 traffic will rise to show the same amount of traffic as the production 1 cluster was showing before. At this point, I can safely upgrade the production cluster because that's receiving none of the traffic anymore. At this point, I think it's important to note that what I mean by safe is very much dependent on how you like to perform your upgrades. Knowing CockroachDB, I would consider a direct upgrade to a live production cluster to be safe because of the way that CockroachDB replicates its data. But your risk appetite might be different to mine, and you might be operating against 2 data centers where you prefer to stage the rollout. Let's take a look at the progress of the production 1 upgrade. And once that upgrade is complete, I'll stop the workload and I'll show you that both clusters have identical data, confirming that our bidirectional logical replication streams have ensured a consistent view of data in both clusters. That's all up and running again. And at this point, you might want to slowly move traffic back to the production 1 cluster. I will just do it in one fell swoop. Notice there's no impact on production traffic, and this traffic on our production 2 cluster will drop to 0. And there it is. While our production 1 cluster is now the target of 100% of production traffic again. I'll stop the workload, wait a few seconds for replication to complete in both directions. And with these commands, I'll select the number of purchases from both clusters just to show how logical data replication has been consistently replicating data across both clusters during all of this upgrading. And there are 370 purchases in both clusters. That was logical data replication for progressive deployments. If your preferred method of upgrading software is either blue-green deployments or Canary deployments, you can achieve this with 0 downtime thanks to logical data replication.